So it's October 9th, and I had an SI party, and nobody came. It was really sad. And I was giving out $100 bills, and yeah, but there was no one here to get them. So, but I figured I would do a problem anyway, and show y'all, just give you some more examples of things. So in this problem, we are supposed to find VAB, or the voltage across the capacitor inductor combination over here. So the voltage across the part that adds to the reactance. And so we have a current source here, and it's given in the time domain. So we need to cast everything to phasors, because this is much easier to do as phasors. And so first thing we want to do is change it to a cosine. So we'd have 35 cosine 300t minus 15 degrees minus 90 degrees milliamps, or 35 cosine 300t minus 105 degrees milliamps. So this tells us that our current as a phasor, it's in milli, so that's 0.035 is our magnitude, angle negative 105 degrees. This 300 is our angular frequency, that's omega. Okay, so we now know that our current is 0.035, angle negative 105 degrees. As a phasor, a resistor is just a resistor, it's 80 ohms. Now the capacitor, when you write it as a phasor, a capacitor is minus J over omega C, and an inductor is J omega L. So the capacitor, the impedance of the capacitor is minus J over omega's 300 radians per second times the capacitance is 200 microfarads, so 200 times 10 to the minus 6, or minus J over 6 times, let's see, that would be 10 to the 4th times 10 to the minus 6, or minus J over 6 times 10 to the minus 2, or minus 100 J over 6, or minus 1 6 1 4 36 to negative 46, 16.67 J ohms. Okay, now Z for the inductor is minus J omega, plus J omega L, and so that's J times 300 times our inductance is 15 millihenries, or 0.015. So that's 3 times 10 to the second times 15 times 10 to the minus 1 is 45 times 10, or 450 ohms. That can't be right. 15 times 10 to the minus 3, so that's 10 to the minus 1, or 4.5 ohms. That seems better. Alright, so now I have the impedance of the capacitors minus 16.67 ohms, and the impedance of the inductor is 4.5 ohms. And before I go any further, let's see if I have those right. Let's see. Minus 16.7 and 4.5. That's what I got. Okay. All right. So now we can look at this circuit. And our current source, let me make sure I had that right too. 0.035 angle, negative 105, yes. 0.035 angle, negative 105 degrees. And we had a resistor of 80 ohms. And now I can combine my two impedances over here at minus 16.67 and 4.5. Negative 12.17 ohms. Okay, so now I'm looking for the voltage across this. So I could do a current division. I could put these in parallel and figure out the total voltage. See, the voltage across the resistor will be the same as the voltage across the inductor, the capacitor, because they're in parallel. I do like current division. I could do a source transformation and then do voltage division. But if I have to do division anyway, I might as well do current division. So let's get the current across this branch right here. So the current across this branch, so IZ capacitor inductor, will equal 0.035 angle negative 105 degrees. And then by current division, it'll be the impedance of the other branch over the sum of the two impedances. This has a J in it. These are J's. Minus 12.17 J. Okay, so now I will take 0.035 0.035 angle, that's in my complex menu, angle negative 105 degrees. These calculators are great. They're only $20. If you're looking for them on Amazon, TI-36X Pro. Times, and then as a fraction, I have 80 over 80 minus 12.17, and then I. So it gets me in A plus BJ form, negative 0.0038 minus 0.0344J or in polar form, I'll just go to second complex, change to polar. 0.034 angle negative 96.4. 0.0346 angle negative 96.4. amps to make sure that's right. That's what I got, yep. Okay, so now to find the voltage. V, so this is actually I as a phasor. V equals I times Z. So our voltage as a phasor will equal 0.0346 angle negative 96.4 degrees amps times the impedance, which is negative 12.17 J ohms. So now if I multiply that, so that just takes my last answer times negative 12.17 J. So times negative 12.17 J negative 0.419 negative 0.419 plus 0.466 J, or J 0.0466. But I want to put this in the time domain, so let's change it to a phasor. So go to complex, change to polar, 0.421 angle 173. Volts, let me check that. I have the wrong angle there. Let's see. How did I have the wrong angle? Let's see. There's negative 12.7 J. Look at what I did on the calculator. I think that was right. So that was my current times my impedance, which was negative 16.17 J plus 4.5 J slightly different. .403 angle 173. Pause this for a second. Okay, as far as I can tell, I did not do anything wrong. So we have 0.407 angle 173, and so if we want to convert this back into a phasor, we can say that VAB into a time domain, VAB equals 0.403 cosine, and then you have the same angular frequency, 300t plus 173 degrees. And then I think why the solutions manual did this was once we have it here, we don't have to have a positive number anymore. So if we make this now negative, this is volts, 0.403. Actually, I think there was a typo in here somewhere. I think it is 0.42. Cosine 300t plus 173 minus 180. So minus 180 because we made this negative. So negative 0.42 cosine 300t minus 7 degrees. And I think they just did that to make this number between plus or minus 90, but it's not necessary to do that. It's just how the solutions I was looking at did it. So there we go.